All right, so welcome back. This slide and concept is already covered in one of the honors videos. If you're in regular college prep chem, just the Regents level, this is not in your notes, but it would be helpful for something coming up. So you can either print this slide out, or you can just listen, or write it in the margin of a blank page or something. That's fine. So we're talking about water. And so when you have water, this W means water. This is K sub W. It's a constant talking about water. So if you have a sample of water, which of course you know is H2O, H2O is going to break apart into its component ions, which is H plus and OH minus. And since we also have some water just floating around, it's also going to grab on to some H plus and become hydronium. So water can break apart into both of those, and it can also grab on. So let me get rid of this for a second. So this water constant, I'll change the color to something darker. The water constant is equal to the concentration. These brackets mean concentration. So the concentration of H plus times the concentration of OH minus. Now, there's no numbers in here. If we were to actually calculate, we could put numbers in there, and we would get this value. So 1 times 10 to the minus 14. That's pretty small. Water is neutral, as you know, from pH, but if you didn't, that would mean that, if this is neutral, you wouldn't have more H plus, because that would make it acid. You wouldn't have more OH minus, because that would make it base, so they have to be equal. So what would this be? 2 of the same numbers timed together is going to give you that. And of course, you can't see all of it. I apologize. So this means the H plus concentration is 1 times 10 to the minus 7. OH minus is 1 times 10 to the minus 7. And if you know anything about water, you know that the pH, whatever that is, we'll talk about it, is 7. So if pH is 7, that's where it's derived from. I have not seen KW on the Regents in a while, but it's probably on some of my review, and it's good to know. So we've been talking about different definitions of acids and bases. We talked about Arrhenius acids. We've talked about Bronsted-Lowry acids. We have not yet talked about pH. But in general, an acid is a solution in which there's more H plus. Concentration. That's what those brackets mean. So the amount of H plus is greater. The molarity is greater. So it's greater than that. And remember, capital M is molar, meaning molarity. If you have a basic solution, which, by the way, the word alkaline means basic. So if you have a basic solution, think about it. You're going to have more of the base particle, OH minus. And so it would have a larger concentration than that. If you are neutral, remember, you would have equal amounts of H plus and OH minus. But since we are not neutral in acids or in bases, you would have a skew, either more H, lower pH, greater OH, higher pH. Speaking of, what is pH? So notice that the H is capitalized. That's because it's about hydrogen. Lower P, depending on who you talk to and what textbook or website, it could stand for potential hydrogen or the power of hydrogen. So up for debate. So calculating pH, there's a formula. The formula is not in the Regents, but hey, why just focus on the Regents? So the formula for pH calculation is negative log of the H plus concentration. Now, scientific calculators should have a log button. The 4-function cheapo ones might not, but thankfully we're not going to spend too much time on this, but you do need to kind of understand. So I really like this diagram. So pH didn't include 0, that's okay. So the more acidic you are, the greater concentration of H plus. And you notice as the pH increases, the H goes down. As the pH decreases, OH goes down. As the pH increases, OH increases. So at 7, you would have equal amounts of H plus and OH minus. as the H plus concentration decreases, OH minus concentration increases. So remember this and how this is neutral. You got that similar concentration. I really like that. So as pH changes, the pH is a logarithmic scale. So each jump on the pH scale is like a 10-fold change. We don't get into logs so greatly in Regents chemistry. In SUPA or AP, you would definitely need to get more into it, or college level, with actual calculations using that formula. Basically on the Regents, it's going to say, who's a stronger acid, pH of 6 or pH of 3, and how much stronger is it? And so you might know that pH of 3 is a stronger acid, but how much stronger? So let's use this example instead. pH of 3 to pH of 4. So if we're talking about acid, pH of 3 is stronger. pH is a stronger acid. How do I know it's a stronger acid? Well, acids have those low pH values. How much stronger? Well, to go from 3 to a 4, that's 1 pH jump. So it's 10 times stronger. 10 times stronger. pH of 3. Sorry, that's important. pH of 3 is a stronger acid. It is 10 times stronger. Now, I think this was the example I was talking about earlier. Go back and rewind. pH of 6 to pH of 3. Now, of course, when we compare, you could do either way. You could say pH 4 is a 10 times weaker acid. You could do that. All right, pH of 6 to pH of 3. So we'll talk about it with 6 first. So 6 is further up the pH scale, which means it is more basic. So weaker acid. So you can say pH of 6 is a weaker acid. Weaker acid than pH of 3. Let's talk about how much weaker. So we've got pH scale. So we've got 10 times. 10 times 10 is 100 times. 10 times 10 times 10 is 1,000 times. So it is 1,000 times weaker than a pH of 3 acid. You could say pH of 6 is 1,000 times stronger base, or you could speak in terms of the pH of 3. It doesn't really matter. All right, here's one of those calculations. So my calculator's over here. All right. First of all, if you do any of these calculations and you get an answer that doesn't make sense in terms of the pH scale, so like you get an answer of 25, something went wrong, or negative 1,002. So it should be within the realm of, 1 to 14, your final answer. What is the pH of a solution if the H plus concentration is this? Okay, so pH equals negative log of, now the H plus concentration is 1.4 times 10 to the minus 4. Here's some good sign notation practice. Because everybody's afraid of sign notation, let's put it in the long form. So negative 4 means a number smaller than 1. Here's my decimal place. So I move the decimal point to the left, 1, 2, 3, 4 spots. So that's 0, 0, 0, 1, 4. Negative log. Okay, so here I am in my calculator. I'm going to put negative sign, log, and then it opens up. Now, by the way, I have a TI-30X Roman numeral 2S scientific calculator. Maybe you don't. So everyone's a little bit different in the order in which you would put it into your calculator, but mine just opens right up with a parentheses. So I'm going to put 0.00014 in close parentheses. I'm going to get a value of 3.8538, blah, blah, blah. If I really wanted to be a sig fig fanatic, I'd say, okay, 2 sig figs, 3.9. So this makes sense in terms of the pH scale, so it's between those values. And you can say, okay, so if the H plus concentration is this size, and I have a pH of 3.9, that's a moderately strong acid. Pretty strong. Okay. Have not seen those kinds of calculations on the reagents in a long time. So I wouldn't worry about it for the reagents, but it's good to know. Oh, let me get rid of all that now. Now that I've done that, erase. So here's another way the reagents could ask you questions, and on some of my review, there are questions like this. The reagents may ask you to calculate pH given the molarity. In this case, you would simply move the decimal place until you get a whole number 1. Okay, so what the heck does that mean? So here's an example. What is the pH of a 0.0001 molar HNO3 solution? Which, by the way, if I asked you for that acid's name, where do you find all names of acids? Well, not all, I suppose, but a bunch of them are listed on table K of the reference table, and you would look this up, and this is called nitric acid. Okay, so what is the pH? So you will simply move the decimal place until you get to a whole number 1. So that's going to be a 1, a 2, a 3, a 4. pH of 4. Okay? Oh, I had that? Oh, look at me. Last thing I want to talk to you about. We just talked about pH. There's also something called pOH, so the hydroxide. Since the pH scale goes from 0 to 14, your pH value plus something called pOH value equals 14. We just talked about this. Since Kw is 10 to the minus 14 at room temperature, a little bit warmer, if you know H plus concentration, you can know OH minus because they have to equal 14. If the pOH of a solution is 8, are you acid or base? By the way, pH will tell you if you're acid or base. You know that. Acids are the low, we'll call it 6.9. Bases are the bigger. 7 is a weird range. Just be careful with that. All right, so if pOH, we are looking for pH. pH, I don't know. pOH is 8. It's got to equal 14. So how do I solve for pH? How about we subtract 8 from both sides? pH is 6. Okay, now what do I do with that information? Okay, so I know the pH scale. If I have a substance with a pH of 6, that's going to be an acid. Okay? And that goes along with a worksheet that is in the book, pOH. I haven't seen that too much in the reagents again, but it doesn't hurt to learn some chemistry just for the sake of learning chemistry. All right, I hope this helps, and I'll be helping you soon with something else. All right, thanks guys. Take care.